Hi, my name's Meghna from the Science Translator. Today's lab is about endothermic reactions and how we can use them to make ice cream at home. Pretty sweet, right? If you like this video and want to learn more, check out my website, link in the bio, for my chemistry bootcamp. That's all for now. On to the video.
All you need for this at-home science lab is some heavy whipping cream, some sugar, vanilla extract if you can swing it, if not, that's okay too, some salt, 2 Ziploc bags, one about a gallon size and another just a sandwich bag, some measuring spoons, and 4 cups of ice, which is currently chilling in my fridge. Let's get started. So your first step is going to be making sure that everything is clean and that you have a parent or guardian either with you or who gave you their permission to do this on your own. The number one step for science is making sure you're safe. Get that out of the way. Now that you've done that, we're going to make our mixture in our small bag. For this, you are going to need a 1/2 cup of heavy whipping cream, a tablespoon of sugar, and just a dash of your vanilla extract. So let me get that done real quick. Now that you've got your ice cream mix sealed off in a little bag, you're going to put that to the side, make sure it's completely sealed, and you're going to start making your freezing bag mix. For this one, you're going to need your 4 cups of crushed or cubed ice, as well as your 1/2 cup of salt. After a brief struggle with my ice maker, here we go, 4 cups of ice. We're going to take our 1/2 cup of salt and pour it in. Seal the bag up, give it a little bit of a shake. Okay, and now we're going to take our small bag and we're going to put it inside of our big bag. Make sure that it is sealed really tight. We don't want salty ice cream. And now you're going to shake this whole thing for 5 minutes. Feel free to grab a kitchen towel if the cold is a little bit too much. I know it was for me. Okay, it has been the 5 minutes, and so we're checking back in with the ice cream. I had to double bag it because the condensation on the outside of the first bag was making a bit of a mess. But let's open it up. And the ice cream is, yeah, it's pretty solid. Oh, that's actually way more solid than I thought it was going to be. I'm going to take a second and clean it off, and you should too, because again, nobody likes salty ice cream. And let's give it a taste test. Okay, I've cleaned the bag off and I've got a spoon, so let's give this a taste test. Alright.
If all you wanted was an ice cream recipe, stop here. Otherwise, stick around for the science behind the endothermic part of the lab.
So at least the texture's right, if a little bit clunky. And taste. It's ice cream. If you want some ice cream now and you've got any of these ingredients just hanging around, then give it a try.
Now that we've done the lab, let's get into the science.
Why did we add salt to the ice? So when we started off with this experiment, we already had ice in the bag, and we all know ice is cold on its own. So why did we add salt, which was room temperature, to make the whole bag colder? Well, the answer lies in 2 important processes that happen inside the ice when you add salt to it. The first one is called dissolution, which you see right over here. When you added the salt to the water, the salt actually dissolved inside the water. Now, you don't need to worry too much about the specifics of what dissolving means, but what you need to know is that when the salt dissolved, the water molecules liked the salt better than it liked itself, meaning that they were less likely to clump together to form ice than if you just had pure water. The second process is melting. Here you see a solid, a block of water molecules, and you see individual water molecules kind of moving away from this giant block. This is basically what's happening when something melts. The molecules are getting further apart and they're starting to move a little bit faster. Now, for these molecules to move apart, what they need is extra energy, which has to come from somewhere. The process of taking in extra energy from the surroundings is called an endothermic reaction. So an endothermic reaction is when a substance, or more accurately a system, takes more energy than it gives its surroundings. Endothermic reactions end in colder surroundings. When we ran this experiment, the system was the water molecules themselves, which needed extra energy, and the surroundings was the whole thing, the ice in the bag. When we measured a colder temperature coming from the bag, what that means is more energy was moving from the bag to the water molecules themselves. And as it goes on to mention, the salt dissolves in water, which stopped the water from forming ice. When we form ice, we give off energy. So by stopping that from happening, we ended up in using more energy than we gave off. This means that the surroundings got really cold, which means the bag got really cold, and the ice cream was able to freeze faster. And that is why we used salt in the ice.
Thank you for watching, and I hope you enjoyed that and learned something. If you have any suggestions on ways to improve, please let me know. Stick around for the next video, and until then, get out there, get curious, and happy sciencing.